Hello everybody, welcome back to the channel and welcome to a new episode of Arnold Repairs. This is my motorcycle and yesterday I was working on it. I wanted to do some basic maintenance. That's stuff I do for my hobby and I don't want to film everything, so I didn't film it. Basic maintenance means an oil change, checking the valve lash, checking the chain, lubricating the chain, look at the brakes, all that kind of stuff. And also I wanted to add these little running lights. These are bright yellow and white running lights, and it comes with a switch so you can select the colors. But anyway, I wanted to tinker with that and I did that off camera. But I had to do some measuring to the electric system, and I started the engine with the engine off. You switch the ignition on, you have around 10 volts of power supply. But I also needed to perform some measurements with the engine running, and that's when I was reminded that I may have a small problem with this engine. I already took the engine out, and let's head over to the bench and I'll discuss the problem I think I have with the engine. So here is the engine. It's a 50cc 4-stroke. It's based on a Honda design. Only Hondas have the cylinder vertical, and it's not the same as the Honda CB that many people tend to think, and I know that for a fact because I rebuilt hundreds of those Honda engines. But anyway, it has done 21,000 kilometers. It's a hard-working engine, but it's reliable, but not the most powerful. And the reason that it's not super powerful is that it's only 50cc and my bike is Euro 4 emissions compliant. Now I'm going to talk a little bit about the emission system on this bike, and if you want to skip that you can go to this timestamp or follow the chapters on YouTube. Over here on the floor is the exhaust of the bike, and you can see it has a catalytic converter. There's a 4-wire O2 sensor which mostly acts as an air fuel sensor. There's a carburetor. Now let's head over to the right hand side of the bike, because on this side is an adjuster that can adjust the air fuel mixture on the fly. So there is no set screw for the air fuel ratio that you have on a normal carburetor. And over here just below the battery there's a small ECU that controls everything. Now, how does it work and what are the effects? Now, personally, I don't have any issues with these emission systems. I've been driving classic Honda bikes, smaller bikes, for years and years, and they were always running a bit too rich. That's how I set them up, because I do a lot of driving in the summertime, and to prevent the engines from overheating, to have them run a little bit cooler, I had them run on the richer side, but I can't do that with this system. The benefit of this is that it never smells of fuel. It has a very clean combustion and it never stinks, unlike the Hondas, which always had some petrol stench to it when you drove along. This doesn't have that, and that's the thing I like very much. However, on warmer days, especially when the temperatures are approaching 30 degrees Celsius, the air fuel mixture is toned down so much that you lose a lot of engine power. So when you do a nice long drive in summertime, you can really tell that the engine is having much less power. When you go driving the same day in the evening time, when it's cooler, when the air is cooler and you have more oxygen in the air, you can immediately tell that the engine is much more powerful. So that emission system in that sense restricts the power very much. And at a point in 2022 I was fed up with that. After a long drive, when you did a long stretch of driving, you stopped for an intersection and I wanted to pull up again. The engine almost stalled. Sometimes it even stalled when I was crossing the intersection, and that is dangerous. So I took measurements. What did I do? Let's head back over to the bench. So that lack of power on warmer days was kind of bugging me, especially when I figured it became unsafe. So what I did, instead of removing all the emission equipment, I kind of like the emission equipment because the bike doesn't stink and fuel economy is great, but I wanted to add a little bit more power. Now there's not much I can do by tuning the engine and changing the jets in the carburetor, so what I did, I bought a big bore kit, and it consists of a cylinder and piston, and it works with the standard 50cc head. I've built the same configurations in the past for people on those smaller Honda 4-stroke engine, but it's not ideal. In the Honda configuration you had a piston that was kind of adapted to go into the smaller head, and you had a huge end compression, and those engines always would go kaput within 5,000 kilometers because the forces on the big end bearing, the conrod bearing of the crankshaft, were too high. So what I did with Hondas, when I installed a bigger bore, I also installed a larger cylinder head with a larger combustion chamber and larger valves. It was a much better setup, but unfortunately those cylinder heads are not available for this type of engine, at least not over here. So they sell kits with a larger bore, and the piston is adjusted to work with this head. It's not ideal, the valves are basically too small, and you do get a little bit high end compression. I do not have the impression that the end compression is too high in this engine, but I am beginning to suspect that the big end bearing, the conrod bearing on the crankshaft, had took a beating, but also it could be the clutch in there. So I'll set the camera up on a tripod, and let's start by removing the clutch cover. I already drained the oil, that's over here. This is a small drawer to keep my the parts in. And there it is. Put it aside, and I leave all the bolts in. So, not sure if you hear this. Look on the clutch assembly. It's a 2-plate wet clutch, of course. And over here, this is the oil pump. Over here, this is the pickup point, and there's this small gauge in there which I'm going to pull out when I have the camera on a tripod, and that tells us a lot about the condition of the engine. Usually there's nothing wrong, and this engine had its oil changes in time because I'm the owner, so I'm very meticulous about maintenance, and yeah, it looks brand new. It's super clean. So take the needle nose pliers and pull this out. This is a strainer. There is some residue in there, but it's mostly fibers. Sure if the camera will focus on there, but there are some small fibers on there. Nothing to worry about, no metal parts or anything. So let's give this a quick wipe. What I want to do now is take off the clutch, and there are 4 Phillips head screws in there, and they can be a bit tricky to get out, but I'll give it a try. Yeah, super tight. This one is not. Okay, I drilled the last one out. These are 5mm screws. I use a 6mm, and it only took 10 seconds to get this little clover leaf cover off. Here it is. So there's the clutch housing. There's a small gasket over here. If I can get it off without breaking it, would be nice. There it is. Now this clutch housing also acts as a filter. It's kind of an oil centrifuge, and the residue gets stuck in these corners over here. So that's, yeah, mess in the oil that's been centrifuged towards the outside. That's something you need to fix, and usually there's always a lot of this stuff in here, especially when those engines have done over 50,000 kilometers. Now we need to get this off. This is a nut which you need a special socket for. I'm going to show you that in a minute. And there is a securing plate, a locking plate behind there. Once we have that off, we've overcome the biggest hurdle in the disassembly of this engine. So this is the special socket I spoke about. It has a 3/4 inch drive inside there, 4 pins on the outside. This is for this clutch, and when you have the older Honda semi-automatic clutches, you have to use this part. And I'm gonna use my impact friend over here to get it off. So I have to bend this one tab back. If I can get a screwdriver in between. And I'm aware I'm using a chrome bit on the impact, but if it's correct, it doesn't use much force. And there it is. Easy peasy. The first time I had to do that without that tool, I struggled a day with it. So here is the nut off. Now I can take the washer out. And there's this convex concave washer. And it says outside on one side, and that's facing towards the outside. And then there's the locking tab ring. Put that aside. We can take the clutch off. And there it is. Now this looks good. No worries here. Well, this is different from what I'm used to see. Oh yeah, and there's another difference I see. Just said that the oil pump is driven off the other side from the timing chain, but it's not the case. I can see there's a secondary gear. There's this secondary gear over here and a plastic gear on the oil pump, and that drives the oil pump in these engines. So you learn something every day. There is no need to take the oil pump off, and I think I'll leave that in place. I'm gonna disassemble the other side of this engine so that the starter mechanism is disconnected. You could hear that mechanic noise when I rotated the clutch, but then I realized that of course has a starter motor and a starter mechanism. So let's take that off first. There is the starter motor. There it is. As you can see, the flywheel and the starter mechanism came off. I wanted to use my bearing puller, but I didn't need to. I had it attached and I screwed it tight with my hand and it popped off. So there you have it. Now we already have a good look on the inside of this engine, and again everything looks clean. You can see there are a lot of oil spills, but the oil is also very clean. I'm really happy with how this looks on the inside. I did have some issues with the timing chain after I changed the cylinder, and I thought there may be something wrong with the timing chain guides, but as far as I can see from here, they look nice. But it's not uncommon for these engines to develop a little bit of timing chain noise after 10,000 kilometers. It's just nothing to worry about. It's not nice to hear, but on the other hand, it's no biggie either. So next thing will be to take the cylinder head and the cylinder off. Before I can do that, I have to remove the timing chain, which I'm going to do now. You have to know there is a long bolt running from this side through the camshaft that holds this round cover over here. There it is. You can see it's a real long bolt that screws into that round cover. I'm using the clutch housing on the other side to keep the crankshaft from rotating. There they are. Gonna remove the timing chain tensioner, which is back here, otherwise it'll jump out completely. and there's no need for that. Just pull this one out, and there is this crankcase breather tube in the way. It's in a very weird position. It's one of the flaws of this design, that it runs in between the frame. It's really cramped in there. Let's put that aside. If I can find a better solution, we'll implement that while I'm doing this. There it is. Just 10mm cap nuts. Now the top cover comes off. This is basically a rocker cover. Let's put this aside. Now we can remove the timing chain sprocket from the camshaft. Let's just drop it down and look for wear at the timing chain, but this looks brand new. It's in very good condition. Let me see if I can get this out. No, I need to remove that. Let's focus on the cylinder head first. And there is this screw. That's super untied. So it's quite a long screw with a very thin washer. Apparently it's good for something, and at least it wants to come off. And that's our cylinder head removed. And that's the tiny little valves you can see, and this is how much the big bore kit is larger than the original cylinder head. This looks good. Let's remove the head gasket. I need to get a new one for that. I need a new gasket kit anyway. Yeah, let me remove this. There. Hope it shows on camera, but there's this small plate over here keeping the timing chain in place. Whoops. So that's the plate removed. Just remove the timing chain. There it is. Dowels here and there. Let me pick them out, and there's a small O-ring, tiny O-ring. This is the bottom right stud, and as with the Hondas, the oil is transported along this stud to the cylinder head. It's sticking on the dowels. Man, the piston is stuck in there. Okay, doing a quick look off camera in the cylinder barrel, and that looks really good. There is the wrist pin clip out. Piston pin itself. Look at the piston, there's a little bit of wear on the back side, only minute. And the piston rings, the piston ring glands look just great. No worries here. Okay, let's give the workbench another wipe. Okay, now I want to split the engine, so all of this needs to come up. It's a gear shifter arm. It's this over here. The gear shifter itself, the foot pedal goes on this, and there's this what we call the glover lever. It's a selector in its arm, and this is the Kickstarter, which I never use. But anyway, I'd rather have this something like this. I hope don't bend that stud all too much. Pretty confident that I'm not. Darn. It's a bit unorthodox, but I'm going to use the impact for that. It's a 10mm. There it is. Get me a new drawer. Let me see, there's a lot of tension on there. Now we should be able to pull the gear shift mechanism out. This is where the foot pedal mounts to. And it's super tight. And there it is. Always be careful when you're using or working around these corners. I try not to put my screwdriver on there and make a divot in there. That would cause a leak. But sometimes you gotta do what you gotta do, and in that case you just have to be careful. Now this should come off. Or is there? No, there's another circlip on there, and I forgot my circlip pliers. So I have to make a run back home to get them. So there's the circlip, and this is the return spring for the Kickstarter and its stopper off. Okay, so now we can split the crankcase, and there's only one bolt we have to take in mind. On the right hand side, let me see, that's off. And now it's just a matter of taking the bolts on the left hand side of the engine case, crankcase out, and then we should be able to split the entire engine. Now I should be able to split the crankcase, but I want to have it rested on the left hand crankcase and find pieces of wood so I can have it on its side. Found a slightly different solution. Instead of blocks of wood, I found a couple of paint cans. Now I should be able to split the crankcase between. I want to try to keep the center gasket as much intact as possible. And there we have it, folks. That's the inside of the motor or engine. Always confused by those terms. There's the crankshaft. Yeah, and there's the play. Now I can feel it. And it's minute, but it is there. So, clones. Now let's have a look at the gearbox. Oh, it's nice that the kickstart lever is held in place with this mechanism over here. I think that's a real nice touch. Get that out. Okay, the next step will be to take the gearbox itself out, and I want to keep that in one piece. Reason being, there are lots of those tiny intermediate washers and spacer rings in between. There's a circlip, and that order is very important. And I've seen it a lot of times go wrong with the Honda engines, where there is a mistake in one exploded view where the position of a spacer and a circlip are changed in a drawing, and it means if you assemble it like on the drawing and you put it together, the first time you shift from second to third gear, this moment you shift to third gear, the engine will lock up immediately because the second gear isn't free yet and the third gear is engaged, and you have two gears simultaneously engaged. That'll stop the entire engine. And worst case scenario is you can do all of this over again with a lot of engine damage, especially the gearbox. The teeth of the second gear break off in that case, and those Honda gearboxes are really hard to find, so be careful with that. And that's also the reason I don't have a good drawing for this gearbox. That's also the reason that I want to keep all of this together, and I have to be careful that I don't lose it. So I made a quick run home. I got some zip ties over here, and I will clean up my mess, don't worry, but I want to have this done today. So do you want to stay on? Yep. There is an Allen key which I need to take out, and there's a copper thingy over there for a gear indicator thingy. Let me show you up close. This is the thingy that sends the gear position to the indicator and the speedometer. Now with that, I should be able to tap the entire gearbox out. Oh boy. And that's the entire gearbox assembly out. The nice difference between this and the older Honda engines is that it has a normal roller bearing, whereas the Hondas had a smaller needle bearing. This is a much better bearing, of course. So I'm gonna pull off this gasket, and I have thought about buying a parts washer again so I can clean all of this neatly, and then I'll see if I can get some gaskets, and then we can put everything back together after I did some measurements on the conrod and the crankshaft. Okay folks, we have a plot twist. It's actually a week later. I picked up the parts last week, the gaskets, and now it's time for me the clickbaity thumbnail that I have just decided upon and that I yet have to make. So what happened? I went to the parts store where they already have sold a lot of these mesh bikes, and they also specialize, or they mainly specialize in the older Honda 4-stroke mopeds and motorcycles, and I have rebuilt many of those engines. Here's a link to a video. And I discussed with the owner the quality difference between the mesh and the Hondas, and it's obvious the Hondas are of better quality. The older ones already were, and the new ones are much better. But I said, well, I kind of surprised by the quality of these engines, and I asked him, what are your experience with the repairs of those mesh engines? And he looked at me and he said, oh, we never repaired them, we just replaced the engines. They are of such poor quality, we just throw them in the bin. And they are an official dealer. So I asked him, well, what are your experiences then? Well, he said, well, these engines last 25,000 kilometers, and when they break, it's not worth the effort because labor is too expensive. A new engine just costs 300 euros, so what we do, we replace the engine in its entirety. Costs about an hour, and that's the cheapest option for an owner. Well, I said, mine's at 21,000 kilometers. Well, he said, then you got 4,000 kilometers to go. And he also told me that the longest lasting MAS 50cc engine he saw lasted 28,000 kilometers before it broke down and had to be repaired. Well, if you've seen the disassembly of this engine and my response, well, you will have noticed that I'm actually surprised by the quality of this. Yes, you can see it's of a lower quality than the Honda engine, but all in all it's not too bad. It looks pretty good to me. So I asked, what's the first thing to break down then in these engines? He said it's always the gearbox. If something fails, it's the gearbox itself. They kind of explode after 25,000 kilometers. So I am going to check mine. And he said what also happens a lot, and that's mainly down to lack of maintenance. A lot of younger guys drive this bike and they forget to lubricate or clean the chain. They start to rust, they wear very quick, and what happens is when the chain snaps, it always snaps. Here is the drive sprocket over here. It snaps, it gets jammed in between here, so the casing breaks, and all of a sudden the gearbox stops, stopping the engine, jamming the engine, and the teeth break off several gears. Most it's in 4th gear when it happens. So then you have to replace the entire engine because of the crack in there, and you need to replace the gearbox. So the gearbox seems to be the weak spot of these engines. So what I'm going to do is inspect my gearbox, and I'll show you on camera what my findings are, and I have an idea. Hold on a second. So what I have here is an original Honda 4-stroke engine, well, minus the cylinder head, because I sold that, and that's the last one I kept in stock, and it's been lying in the workshop for years now. So my plan is I'm going to disassemble this engine, compare the gearboxes. I know this gearbox has done, well, less than 100,000 kilometers, so that's much more than what my mesh has done, but in my experiences these Honda gearboxes never fail. They are very good. So what I want to do is disassemble the Honda block, the gearbox, make a comparison, and if things are interchangeable, because these engines are basically the same, I'm going to install the Honda gearbox in my mesh. But I'm going to do that off camera. Well folks, it's the following day and I've done some experimenting with the gearbox. This is the gearbox coming out of the old Honda, and well, the dimensions are different. This end will never fit in because this diameter is too small. Same goes with that. In the Honda these go in needle bearings, and the mesh has ball bearings, and also the length of the shafts don't correspond. However, this spline part over which some of the gears slide, the gear selecting gears, they do work with the mesh gearbox, but the only problem is that the first gear, which is this one, this is the drive shaft, which is driven off the clutch. This is the driven shaft with a change sprocket on there, but this gear is made out of one piece with the shaft, so that's not interchangeable. And then it has to work with this. This doesn't play nice on the mesh gearbox, so I decided not to transfer the gears to the mesh transmission. However, 4th gear did play nice, and 4th gear was my problem. The step between 3rd and 4th was too small for my liking. You could see that the Honda gearbox had a much larger step in there, and 4th gear is actually an overdrive. Sorry. So I tried to fit that on the mesh gearbox, and that's where I'm at this moment. So let's move the camera over. And there we are. I hope it shows well. But this is 4th gear, and this is 3rd gear that slides, that wants to catch in the Honda gear set. And as you can see, those gears are almost the same size. It's a direct drive. It's a much larger step than what was in the mesh. The only problem I have is that in the Honda there is a spacer in between these gears, and this gear is not as wide as the one in the mesh, and I don't want to have this gear sliding back and forth on the axle, putting a strange load on there. So I used a small spacer, namely this one, as an extra, and when I put this in on the mesh gearbox and put the gear in, if it wants to work with me, then I need to put this ring in, and that prevents that the gear is running into the engine casing, so it doesn't eat into the aluminium. And same thing is going on here. There's a small spacer ring in here, and well, in terms of size it fits, so I gave this a try. Currently there are 2 gears engaged simultaneously, so I'm going to put it in with the gear selector drum and put the right hand side engine cover on, and then I want to give this a test drive to see if I have clean shifts. Well folks, I'm about ready to start reassembling the engine again, and actually this is take 2. I started filming with the 4th gear set of the Honda N, but when I tightened the engine cases back together, things were jamming, and when I tried the shifting mechanism, it didn't work. So I'm back to the gearbox, the original mesh gearbox, because I'm pretty sure that the fourth gear set of the Honda won't work in this, unfortunately. But anyway, let's go ahead. Let us put the gearbox together. And the gear selector drum on. I have everything pre-lubricated, so it's nice, oily and greasy. And it goes in of the selector drum. Slide in the drive shaft, the driven shaft first. Now it should fall into place. There needs to be a shim over here. Another thing that's important to know is the construction of this. This is the Kickstarter axle, and there is this part over here. There's a sort of a small ramp on here, and there's a ramp on there. So when it's fully returned, then this part, these notches disengage. It should be like this when the engine is running. That means that this part should be up here, so you have to set this correctly. This is the Honda Kickstarter axle, and as you can see, the length is exactly the same. So I could use this, and preferably I would use this. It seems that everything is the same size, but this is easier to disengage. But I hardly ever use the Kickstarter, so I'll just put this in. Only downside is when you fill with this, you have to take everything back apart. And everything is already pre-lubricated. Never put anything in when it's dry. I have to push this to the ramp. And now these notches are disengaged. And it can spin freely. And when I rotate it, now it engages. When the engine turns like this, you get that. That's not what we want. This is what we want. So I put this up here. But now it's time to put the crankshaft in, and it's important to know that there is a tight fit between the outer race and this part over here. So I have everything pre-lubricated. Just check if everything is clean and look at the wear of this tiny sprocket, but yeah, there's nothing wrong here. So you have to wiggle it in a little bit, and now we can put the other engine casing on here. Just want to make sure I have sufficient lubrication on all these parts. And this hole for the gear shift, axle shaft. Did not forget anything. All the tiny things are in place. I already greased the circumference of the casing, so now I can put the gasket on. Already made a cutout for the cylinder. There's a dowel pin over here, that's in the other half of the casing. I would prefer to have it in here, but I can't get it in, and when I try to pull it, I'll damage it, so I'll leave that be. This is the other half. Put a dab of oil on the bearings. See if everything's clear, and here's the other dowel pin. So now we can put this back on. And there we are. Just checking if everything spins freely. And before I'm going to tighten the bolts around the circumference, I first want to test the gearbox. That's very important to do. If you have any faults in there, you have to take everything back apart, and I'm checking the preset of this Kickstarter shaft. Let's turn it around, put some of the bolts in. Next up, we're going to assemble this side. The gear shift mechanism is a little bit hard because these two tiny little pins in here, aren't along the center, so you can only put this selector thingy, we call this a clover leaf, can only go in one way. You can't put it around, and it's pretty hard, and it took me a while to figure it out. 30 minutes to be exact. Now on the other side, on this side over here, I already have the sealant for the gear shift axle mechanism. I have to be careful when I put this in. This goes in first, and I already lubricated those holes. And if you look up close, you can see there is a little bit of damage over here. And I went over with a Scotch-Brite to make sure that it doesn't cause any more damage. I'm gonna be careful to push it through, hoping not to damage the new seal. I installed it with the seal first and then this axle instead of installing this and the seal later on. Now I can make sure that the seal is completely seated. So this already is much better than what it was. First up is this little plate. Not sure how well this shows on camera, but there are some imprints of those 3 larger pins. So that shows you the direction. This mechanism is actually what you feel in the shift pedal. Turn the engine around because the gear shift drum has to be tightened from that side too. And here it is. And on the mesh you have this little thingy. There's a copper washer. Tiny little pin on the other side. Yeah, it shows. That falls into a groove over here. Now I'm going to test the gear. So this is neutral, first gear, second, third, fourth. So shift back to first gear. Goes nice and it works right. Neutral, second, third, and there is fourth gear. And that works just perfectly fine. Now I'm going to tighten down the gear shift drum. I do this by feel. And that's good enough. Okay, the next thing to do, we have to install the clutch, the primary drive, the primary reduction, and the kickstart mechanism. Now we made sure this is set to the right position. So now we have to pull the return spring and the return mechanism in that blocks it from rotating over its ramp. Oh boy. This is good. Now I also want to test the Kickstarter mechanism to see when it returns that the notches are disengaged and everything can spin freely. So it engages. So that's looking good. So we can carry on. First comes this spacer ring. I'm just making sure that everything is clean. And, some parts were on the floor in older things in my workshop over here. Just want to make sure that it is as spotless as it can be. So, and now I should be able to put this on. In here is a bushing. That's very important. Just let me try this. See how that aligns. It looks well. Now we can put the clutch on there, starting with So it took a couple of minutes to clean the inside of the clutch housing. I did not want to take it apart, so I've been careful with brake cleaner. You have to know that the clutch lining is very sensitive to the oil specifications, and you absolutely need to use oil with the specification JASO-MA. That means it's suitable for wet clutches and gearboxes. If you use any ordinary engine oil, like for cars, two things will happen. Most likely the clutch lining will swell, so it's really hard to disengage the clutch. And secondly, the clutch operation isn't correct. The clutch doesn't want to go into a smooth engagement transfer. It either disengages or it engages, and it's solely caused by the wrong oil. So JASO-MA is the way to go. Now we need to put this on. First I put this inside the clutch. Best to take this off and put this in here too. And now find our centers. And there we are. If these centers weren't aligned, this is pretty hard to do. Then comes this ring. Don't think the camera will pick this up, but it says outside on here. Faces the outside. This is a sort of a spring. Put this in carefully. Put it on a few. That'll be sufficient. Okay, clutch is on. Now it's time to put on the clutch pressure plate. And there was one that I had to drill out. I did that off camera. And another thing is, this is a gasket goes in between. You could leave it out. These gaskets are never included in any gasket kit. There was quite a bit in there for 21,000 kilometers. So I took it out and I got a new screw. That one I loaned from the Honda engine. So I'm going to use these crosshead screws again. The reason being my hardware store isn't open anymore, so I had to find another source. So I'm just using a slotted screw. Not using any thread locker in here would be an idea. This gets quite warm and quite oily. So a thread locker basically doesn't do a lot in here, unless you choose a type that you can't get out. And this has to be accessible for the next guy. And always assume that the next guy is you. And finally this little clutch bearing goes in. It's just a tiny little bearing. Slides in, and then there's this cup that goes in. And there is a little spring. This is used to push in the clutch so it disengages, and this part is to get the oil in. As you may have seen, the oil pump is behind here, comes out here. Behind here is a channel that goes to here. There's a small orifice which leads along this dot to the cylinder head, that spot, and the oil feed towards the clutch comes out this section here, goes through the clutch cover right here, and then into the clutch. Start off by installing the dowel pins. Bottom right, top left. My trusty bucket of grease. Put a little bit of grease on here. So just doing this to make sure it sticks. The most important part, the oil filter screen that's in here. That's basically the only filtering that's going on. Now comes the new gasket. Make sure it falls over the dowel pins. That's why I put them in here first. Make sure everything's aligned. And one thing you need to look for is this little part over here and there that operates the clutch. There is an oil seal behind there. There's nothing wrong with that. I'll just leave it be. I clean the inside and the gasket surface. There's a little bit left over here. There also is a lot of overspray from the black paint, so it's not too neatly done. And I'm going to take out the seal for the Kickstarter shaft, because I have a new one. Make sure this is in place. It should just slide on. So now comes an important part. I have to tighten all these bolts around the circumference and in the center here. Problem is there isn't a torque number on there. I always do this by feel, but as a service to you I want to provide a little bit of extra information. So I have my Fanbo torque wrench here, and I'm going to use that to tighten it and to find a torque number, and I'll link that in screen. So I have it set to 12.5 Newton meters, and I think I'm happy with that number. I'm going in a crosshatch pattern. Use a little bit of painter's tape as a guide, not to damage the seal lip. My fingers. Now this is in. Pull that off. That's the one. Just some love taps to make sure it's in straight, and that's good. Okay folks, new camera position. First thing I want to do before I install the cylinder is cut these parts flush. I already cleaned everything, and here's a new gasket kit. Just make sure that this orifice over here, I could zoom in a little bit. There is a small orifice that regulates the oil stream towards the cylinder head. If you get a larger cylinder head or a larger bore, an upgrade kit, you could replace this, drill this up a little bit larger. When it's too large, you have too much oil flow towards the cylinder head and too little going into the crankshaft, so your crankshaft will go kaput. There is no oil seal, so no rubber seal inside this corner. And a final look in this cylinder. That looks good. Pre-lube it. Squirts of oil so that we don't have a dry, unoiled start. This will burn off. Okay. You have to locate the wrist pin, the connecting rod. It can be a bit of a hassle. I'm going to drop it in right away because I have to get that wrist pin clip in first. So this is how I put the wrist pin in upright. So when you want to take it out, you have to push this little tab in, and I want to have this vertically, and I let it rest on a socket so it doesn't sink in. So let's slide the cylinder on over the socket, and now jump back a little bit. There's the oil scraper ring. It falls over its dowel pins, and that's the cylinder in. I can rotate the crankshaft by hand, and all seems to be going well. Okay, let's carry on. So now it's time to put the cylinder head on, but we have to be smart here. And in all honesty, this is take two. Reason being, we have to be smart. We have to install this timing chain guide first. So this goes there. I also bought a set of timing chain guides, and I found that this one had too much play. So here is the new one, and let me remove this. So this one goes right there, maybe insert it from the top. That's a better idea. It appears so. So this one goes in here and it pivots on this bolt, but the problem I have with that is there is a lot of play. So what I discovered, I found a small copper washer, put this on the back, and it fits perfectly onto this this bolt here, and now it can't shake back and forth anymore. Let's see if we can install it. And now, if we zoom in again, all that wiggle is away. And that's what I call progress. Here's the head gasket, which I do not lubricate, but I do need to put some dowel pins in first. It seems to me one should be going there, and the other one should be going there. Yes, sir. Comes a new head gasket. It's nicely aligned. There should be an O-ring going in there. So I'm gonna use a little bit of grease to make sure it sticks. And now comes the cylinder head. It is a bit dirty, so I'm gonna get a little bit of Scotch-Brite, clean the surface up, and then throw it on. It doesn't need a service. I took it apart last year at 18,000 kilometers. I used a Dremel tool to round this edge off a little bit, because this is where the 50cc cylinder sat, and this is how much the big bore kit is larger, and I wanted to have a smooth edge, so I Dremeled it out. And what I also did, I replaced the valve stem seals. That was necessary. The ones that were in here, the original Chinese ones, were already brittle, so they really needed replacement. I looked at the bearing back then. There's a bearing on this side, and it was running super smooth. And I must say the quality of the bearings in this engine are just good. Nothing wrong with them. There are these shafts. They are over here of those rockers, and they can get a little bit in place. So I'm checking, yeah, this one is binding the lower one. So you take a small screwdriver and you just push it back. Slightly larger small screwdriver, and just put it back, and they can move around freely. Also with the dowel pins. So this is starting to look like an engine again. Now these are directional, and that can take a little bit of puzzling to find out. Let's see how I'm doing. It appears I got it right the first time. Okay. Put this little cover on. Oftentimes there's a small arrow, and this one has a small arrow too. You can see it right there. That needs to point towards the exhaust. Don't forget to scrape the old gasket off. Alrighto. And there are 4 washers, one of which is a copper one. And the copper one sits on the stud that transports the oil towards the cylinder head. Just have to keep that in mind. And again, I do not know a torque number for the head bolts. I'm gonna do that by feel and put a number on it. We should not forget, rotate it a bit, the 5th bolt with a Phillips head screw. And I'm at 12.5 Newton meters here. So again, Fenpo torque wrench, highly recommended. Head nuts, 12.5 Newton meters. I have also bought a new timing chain. A guy from Porto said this is a wear item. I've been hearing the timing chain for the last 8,000-9,000 kilometers, so I thought it would be a good idea to change it out. It's a Japanese brand, DID, so we're adding some quality here. One thing we have to keep in mind, usually on a Honda engine you can set the timing with the marks on the head, and there is a mark over here. There's this small notch, I'll show you in a second. Problem is I only can install the flywheel and have markings on the engine block when this cover is on, so I can only set the timing once this whole shebang is on. But we need to install the timing chain first. So this is the new one, and the lower one is the older one, and it moves much more freely. Of course, there is packaging grease on this. Let's see if we can juggle this in. What I am going to do is put my screwdriver in here. I'm hoping not to have it fall down into the cylinder. Now comes this little guide. I had to do a little bit of research. I expected a space to be behind here. Here's the sprocket for the timing chain, and this is the starter gear. This is the part that goes on, but as you can see on the back there is a lighter edge, and that comes from these surfaces. So this goes on here without any spacer. Just on it goes. And comes the starter gear. The larger gear goes into the back. And now we can put the flywheel on. Just give it a wipe down, a quick wipe down. Just making sure that there is no debris in there. And inside here are 3 rollers. They are spring loaded, and they grab onto this, or this grabs onto this, and it takes the flywheel. There it goes. So now we can get this on. Now here's the signal, the sensor for the gear position. Now this just falls into here, and I sure hope this works, because to me it looks a bit flimsy. Not too happy with that construction. So here's the new gasket. Good quality gaskets, by the way. I really like the fitment. So, and here shows the cover with the electric system in there, and the signal, the pulse reader for the ignition. Does that look? It looks well. So let's slide this over. And there's an O-ring behind here. I'll leave that be. Now I can get my socket on there. Inspection hole, and as you can see there's a bit too much light on there, but those lines line up. Behind there is a small T. It's a bit hard to read over here on camera, but that's the top, that sender, and just before it is an F, and that's for the ignition timing, but this is electronic ignition, so we don't have to bother. And now we have to line up this section over here. I'll reset the camera so you can see what I'm doing. And all the parts in hand. On top of the sprocket, if the camera would focus. But anywho, there's this little mark that has to align with this. So I'm just gonna hook the chain over and see how far off I am. Could use a little screwdriver. This works best without the camera, I just discovered. So So now I have all the timing marks aligned, but we have to keep in mind that we yet have to install the timing chain tensioner, and that can pull it back a little bit. So this is in. I'm gonna push on those on the rear timing chain. It doesn't affect the timing, so the timing is set correctly. So let's zoom out. So what I did, I pushed on the rear timing chain guide, and it doesn't seem to affect the position. This is aligned, that is aligned. So now we can tighten those bolts. We now know that the timing is correct. Do, however, need to keep the crankshaft from rotating. So I'm going to keep the crankshaft over here, just tighten these, and I do this by feel. Always done that, and I never lost a timing chain sprocket. Now what I'm going to do is rotate the crankshaft in its normal rotating. Just do that twice. So I'm going to look at the timing marks. There is fire, there is T, and that's perfectly aligned. So now we can install the timing chain tensioner. Pull out the spring, and since I have a brand new gasket for that, we're going to install that too. And of course, don't forget to reset the tensioner. So just push on the back here over that and then push it in. And now it's ready to go in. And now comes the exciting bit. Tensioner spring goes in. You hear it click. And I can already tell that there is much less slack in this new timing chain. That's what you would expect, but now it shows that was money well spent. This doesn't have to be torqued to spec, just snug, and there we are, even though it clicked. So give this one a final check, one go around. F2. And there we are. Okay. This cover can go back on. Brand new aluminium washer. Okay. So only thing left to do is get the starter motor back in. Check if everything is okay. There's an O-ring on here. It looks pretty good to me. Just give it a wipe with my greasy cloth, so the matte black gets rid of fingerprints. So that's the engine finished. The only thing that's left to do is fill it with oil. I bought this oil, and what's important the camera picks this up. It's in very small print, JASOMA. That's the one you want to have. And it says it's for Honda, but of course it'll work in a mesh. There we go. And I'm looking at the side glass just to see if it's full enough. I fill it up to the brim. Side glass is full. How much do I have in? Don't spill such a waste. So that's 800 milliliters, and that's, I believe, what it is supposed to have. There's a quick wipe down. And I bought this little temperature gauge. Usually it goes in Hondas, which have the filler plug over here. So this part sits in the sump in the oil, and this one, yeah, it needs to have some oil spotted on, but it's a good indicator for oil temperature. My normal temperature is around 80 degrees, and in real warm weather, when I drive full throttle for longer distances, it gets up to 100 degrees Celsius. So that's pretty good for an air-cooled engine. Well, there's the engine, there's the bike it's supposed to go into, and I'll apply some movie magic and do all of this work off camera. I have everything connected to the engine, to the frame. Everything is hooked up. There's one fault, is that the gear shift indicator is faulty. In neutral it says second gear, so I have to look in that. Now I want to crank the engine over and we'll see if it starts. So fingers crossed. So about 11 hours ago I started rebuilding the engine. Now it's in. It didn't take me 11 hours. I had my coffee and lunch breaks, of course. It seems to be running fine. I topped off the oil. There was a small problem with the gear indicator, and for that I had to take the generator cover off and adjust it slightly. So you just switch it on in contact, and I rotated it a little bit, and then now it indicates the gear as it's supposed to do. I also changed the brake pads in front. The brake rotor was good, so I leave that be. I have cleaned the chain. That needs to be lubricated. I forgot my chain loop, and I have to adjust the clutch. But that's something for tomorrow or the day after when I'm going on a test drive. I will be taking you along so you can have a ride with me and see the beautiful surroundings here, because spring is coming this week. Really looking forward to that. Only thing is, I have 2 bolts left. These 2, they come from the mesh. I've looked everywhere and I cannot see where they come from. I think this one went in the starter motor, and I mixed the other one from the starter motor with this one, but every bolt hole has its bolt. Are we done? Not yet, because the original goal was to install these driving lights, but that's something for a next episode, because I need to find or build a converter that converts from 14 volt DC to 9 to 10 volt DC, otherwise they will be too bright and get too hot. But I'm signing off and see you in the next scene where we go for a ride. So that was a cold but very successful test run. The mechanical noise that I've been hearing that started this entire project, well, it wasn't caused by the big end bearing of the crankshaft. I checked it afterwards, I did it off camera, and I checked it according to the workshop manual, the Honda workshop manual, and it's well within spec. The noise is still somewhat noticeable, and I'm beginning to suspect it's the starter mechanism that lives behind the generator here. But all in all, I'm very happy with the bike, with how the bike runs. I also replaced the front brake pads, cleaned, lubricated and adjusted the chain, and now the bike runs as good as new. So the dealer said that these engines typically last 25,000 kilometers, and I'm not sure if I agree with that. If you are a hard user, so you neglect maintenance, you don't do oil changes, and you start a cold engine and start driving off, that's when I can see why these engines can fail at 25,000 kilometers. But I've always been very precise in maintenance, in oil changes, setting the valve lash. And when we took the engine apart, we could see it was very clean inside. There was hardly any wear. There was no significant wear for 25,000 kilometers, or in this case 21,000 kilometers. I'm willing to bet that these engines will at least last 35 to 40,000 kilometers if they are treated well. That's very important. Honda engines are built better and can handle more abuse, but yet they can fail too. Anyway, I'm very glad that things went the way they went, and I'm ready for bike season now, and I'm looking forward to bike season, I must say, and especially the warmer weather, because I'm cold right now. Anyway, I hope you liked following me along, and if you did, please subscribe to my channel, give me a like, leave a comment and put on notification. And if this video was helpful for you in any way, shape or form, and you want to help support the channel, you can do so by buying me a coffee. I'll leave the link down below in the description box. For now, thank you very much for watching, and I hope to see you on the next one. Bye!